In this video, I'll show you some things you should know about plotting big data in Statgraphics 18. Whenever you request an XY scatter plot in Statgraphics 18, if the sample size is large enough, the program will automatically switch from a scatter plot to a hexagon plot. A hexagon plot divides the XY space into a grid of hexagonal regions. In each region, it counts the number of observations. If there's only a single observation in a region, an individual point is displayed. Otherwise, a hexagon is plotted, and the hexagon is shaded according to the number of observations in that region. As an example, this plot shows data for all flights in the United States, all commercial flights, during the year 2008. There were nearly 7 million flights. The y-axis shows the arrival delay of the flights, and on the x-axis you see the departure delay. The dark hexagons here indicate the regions where most of the observations fall. There are two main reasons for displaying hexagon plots when you have a lot of data. First, they show much more detail about the density of the observations in various areas of the XY space. A typical XY scatter plot for 7 million observations would just be a black mass. Secondly, hexagon plots can be rendered much more quickly on the screen than an XY scatter plot with that many points. This is extremely important in Statgraphics, where we tend to maximize and minimize plots a lot, drag things around on the screen, and so forth. As an example, I'll open the flight data file. I'll go to File, Open Data Source. I'll select Statgraphics Big Data File and tell it I want to analyze the 2008 flight data. To create the hexagon plot, I'll go to Plot, Scatterplots, XY plot. On the y-axis, I'll put the arrival delays. On the x-axis, I'll put the departure delays. Instead of an XY scatter plot, since there are over 6.8 million values on the plot, it's automatically plotted a hexagon. You'll notice that I can maximize and minimize the hexagon plot very quickly. I can also drag it around the screen, which I would normally do with any plot having small data. If I tried to do that with a scatter plot of nearly 7 million observations, you'd find it took several seconds to display the XY plot every time it needed to redraw it. I can also still click on individual interesting points and have the information about that point displayed in the upper left corner. There are also several settings on the Preferences dialog box that you can display by selecting Edit Preferences from the main menu. There's a new tab labeled Big Data, which controls when and how the hexagon plots are drawn. The first setting at the top specifies the point, the sample size, at which the program will automatically switch from an XY scatter plot to a hexagon plot. Currently, it's set to switch to a hexagon if it wants to plot more than 100,000 points. There's a second setting to tell it not to plot the individual points in a scatter plot when a graph is reduced. That is, when it's reduced to an individual pane and not maximized. Here I've told the program that if the number of points in a scatter plot is more than 10,000, don't plot the points unless the graph is maximized. You may also specify the number of hexagonal regions dividing the XY space. By default, it will divide the XY region into a 50 by 50 grid of hexagons. The minimum bin size is the minimum number of points in a hexagonal region when the program will switch to a shaded hexagon rather than plotting individual points. By default, it'll show a shaded hexagon if there are 2 or more points in a hexagonal region. Finally, you can specify the minimum intensity of the shading for the bins, the shading on a scale of 0 to 255 at the minimum bin size. I should also point out that this automatic switching from scatter plots to hexagon plots occurs within all statistical procedures. For example, if you fit a regression model and wanted to plot the residuals, you'd end up with a hexagon plot if the number of observations in the data set were more than 100,000.